Hello friends. So once again welcome to my channel, and in this video we will see today how to represent the value. That means what is the value represented by a IEEE notation, means one floating point number is given in IEEE format, then what value it is representing in decimal, that we will see in this video. In our last video we have completed representing a decimal number into IEEE, both single precision as well as double precision. So if it is your single precision, then what is the value represented by your number? So see, already we know that what is our number in IEEE single precision. It is S, it is E dash, it is M. Here 8 bits and it is 23 bits and it is 1 bit. And it is in excess 127 format, that is bias format, right? So what will be the value? Value will be either positive or negative. So minus 1 to the power s. If the number is positive, value of s is 0, right? So something to the power 0 will become what? 1. That means the number is positive. If the number is negative, s is what? S will be 1. So minus 1 to the power 1 will become what? Minus 1. That means the number is negative. We got it? Then what is your this one? What is that? Exponent. Exponent is in excess 127 format. So what is the actual exponent? Actual exponent will be whatever you have stored minus 127. Last time what we were doing? Actual exponent we know, we are adding 127 to store it in this field. Now we are getting back the value. So we need to subtract 127. Point is clear? Then what is the number? Means what is the mantissa part? Mantissa part, actually the number is represented in your implicit normalized form, where the number is represented like 1 point something, and that something is your mantissa part. So 1 point something is your mantissa part. Mantissa part only we are storing. So what is the total number? Total number will be once again 1 point whatever we have stored in the mantissa part. So as a whole, this is the value represented by my IEEE single precision. If it happens to be double precision, what change will be there? E dash minus 1023. Rest all will be same, right? Now we'll see one example, right? Understood. The value representation is understood. Now we will see one example. So this example is given to us, right? So S is 0. So S is 0 means what? Minus 1 to the power 0. What it will be? 1. That means the number is positive. What is E dash? See, E dash will be your actual, means whatever is here, sorry, your E will be, your actual exponent will be E dash, that is stored minus 127. What is this value stored? This is 128 plus 2 plus 1, that is 131. 131 minus 127. So, or you can use your calculator, that binary to decimal. So it is 131 minus 127 we need to do. See here this one. So what is that? Here this 3 plus 1, 4. So your actual exponent happens to be 4. And then what is your mantissa? Mantissa is 1.11. The others are zeros, no need to write, right? 1.11. This part is also clear because it is a normalized number. This part was not there in the stored form, but this is always there. And in the stored form, this part was there. So we have appended both of them together, right? So now see, the value represented is this one. This one you can see 131 minus 127. Why 131? Binary of this decimal of this part is 131. So it is 2 to the power 4. So it is what? Plus 1.11 into 2 to the power 4. So see, if I multiply it by 2 to the power 4, then the decimal point will come here. Another two zeros will be added. The way you do in your decimal, 4.23 into 10 to the power 4. One become what? 42300. Same thing in binary. So it is 2 to the power 4, right? Decimal you can, you know it. But in binary, sometime it may have confusion. So I have shown you the analogy. So it is 31002. And for this, you can find the decimal of it very quickly, right? So it is 28, right? It is see triple one double zero, right? So it is 1, it is 2, it is 4, 8, 16, right? This part are not there. 16 plus 4 is 20, 20 plus 8 is 28. So this is plus 28, right? So this part is clear. Now we'll do one more example. Say we know the value represented is this one. So next another example. This one is given to us, right? So see, this one is, what is that? This one is 128, right? 128. And this one is what? 1.11. 1.11 into 2 to the power what? This one is 128, right? 128 minus 127 will be what? 2 to the power 1. So 1.11 into 2 to the power 1. Number is positive, s is 0, right? So I can write with 1.11.1 I can write, right? So, and what is the decimal of this? This part is 3. Zero point 1 means what? 0.5, right? Right. So it is 3.5. See how to write your that after decimal whatever is right there, how to write the decimal of that, right? Suppose after decimal 0.11 is there, right? It is what? 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. So see this one. If it is 0, I will write 0, right? This is how we used to calculate after decimal point, right? So this example is also clear, right? Then another one more we'll see, this one, right? Then see, they're asking us what can be the maximum value represented by the 32 bits IEEE 754, this standard name, right? Representation, right? So IEEE 754 is for single precision. What is the maximum value? If it is maximum value, obviously it is a positive number, right? So positive number, and already I mentioned that the value of your the boundary values, that is 255 and 0 we can't use. So for maximum value, E days should be what? All 1 1, but that I can't use for a normal number. So if it is maximum, then which bit I'll make 0? The least significant bit, because I cannot have 255, up to 254 I can go. So what is 254? This one, right? It is 254. And what will be M? It is maximum value. So you take all 1 1. So if we take all 1 1, this is 23 ones are there, right? Then maximum value represented. So maximum, see, first I need to know that if it's maximum value they are asking, then it should be the this combination. So what will be the value? The value will be minus 1 to the power 0, that is positive number. Then what it is? 1.1111 up to your 23 bits. Then into 2 to the power 254. 254 is my exponent, right? In your bias format, minus 127. So it will be 2 to the power 127, right? And see, here see, it is 111 into 2 to the power minus 23, because decimal point I have brought to the right. How many places were there? 23 places. You know this in your Mantissa 23 bits are there. So decimal point is brought to the end. That means 23 places we have traversed to the right. So it will be 2 to the power minus 23, right? Now see, this part is clear. Now see this part. See, to explain what is the value represented by this one. How many ones are there? 24 ones are there, right? I'll not write all 21. But see, one thing we know, in 4 bits, if 4 ones are there, what is the value represented? 2 to the power 4 minus 1. What is that? 2 to the, this one is nothing but your 15. So using 4 bits, the maximum value that I can represent means when all 1 ones are there, value is 15. So here how many bits are there? 24 bits are there. So what will be the value represented? 2 to the power 24 minus 1. I'll not find out the value. I'll keep it in powers of 2 only. So this part is nothing but 2 to the power 24 minus 1. Hope this part is clear. And 2 to the power minus 23 into 2 to the power plus 127. What it will become? 2 to the power 104. Right? And see, 2 to the power 24 minus 1. That from this 2 to the power 24, if I subtract 1, it is a negligible quantity. So this is near about. This is not exactly. This will be nothing but 2 to the power 24 only, because this is a very big quantity. From that, if I'll subtract 1, it will be nearly equal to that only. So this how I'm considering for simplifying my calculation. So 2 to the power 24 only left into what? 2 to the power 104. So it will be what? 2 to the power 128, right? So the value represented is 2 to the power 128. This is near about, not exactly. So what I have represented, the maximum value that I can represent using your IEEE single precision, right? Why I have not taken one, that also you know. And for maximum, I should take all one. And hope this part calculation is also clear, right? So this is there for maximum value. Then next I will see what is the minimum value. So if I am going for minimum value, see what is the, see this, in the last slide we have seen the maximum value. Then minimum will be what? The negative of this whole thing, right? Negative of this whole thing, yes or no? Because see, see whatever is maximum, and if I put the minus sign on that, that will be the minimum value, right? So the minimum value will be, see, this S will be 1, all these will be what? This 1, 1 and 0, and this all bits will be 1, 1. Because it is negative, that minimum value. That means whatever magnitude is the maximum, that is going to represent the minimum value, right? So the value will be this only. Same way I will do. So now see 23 places I have brought to the right, sorry, to the left. So means this side I have brought it. So it will be 2 to the power minus 23, right? Then this part already I have told you 2 to the power 24 minus 1. This one will become 2 to the power 104. Simply you know the previous one. So that value minus, if I'll put, that will be the minimum value, right? Minimum means negative side. Maximum means positive side. If I'll say what is the maximum positive value, that is the maximum that we have represented, right? The next one is the minimum positive value. Minimum positive value this time they have asked, not your this one. What is that? Minimum value in your IEEE single precision. So minimum positive value. So S will be 0, obvious. E dash will be, cannot be all 0, 0. Because that already I said that all 0 means special case. So here I will take 1. Why not here 1? Because that will be on bigger side. Minimum value I require. So in the LSB side only, I'm going to put that, right? So by mistake only I change it to this one. Wait. Where we were, this one, and this one. Minimum positive value. So it will be 1 only, and M will be all 0 zeros. What is the value represented? This is a positive quantity. 1.23 zeros are there. Then it is what? It is 1 minus 127. That is negative 2 to the power minus 126, right? And this part is what? 1 only. So this is the minimum value, right? Minimum positive value, right? This is also because these are some probable gate questions, right? The next one is maximum negative value. So maximum negative value means what? S will be 1. Whatever we have done in the last example, you put the S equal to 1. That is the maximum negative value. So S will be 1, and all this 0, 0 and 1. This is this. So similarly, this one will be minus only. The same example, only minus only. Hope you have understood why I have considered this one, right? Maximum negative value. So maximum negative value means magnitude is the smallest one, right? That is the maximum negative value. S is 1. And if this is 1 is this one, then this calculation will give me this value. So as a whole, this is minus 2 to the power minus 126. So here we have seen how to represent maximum and minimum values. Sometimes in your gate questions as well as university questions also, exam questions also, you may be asked to find out what is the maximum and minimum values. So first of all, you should know that these are the combinations I have to use. After that, you need to find the value, right? So this much is there in this video, and in our next video, I'll see we are going to see denormalized number and all. Till then, thank you. And if you are getting from my explanations, then please do not forget to like my videos and subscribe to my channel. Thank you.